2020 question 6, differentiation from first principles. So those of you that have practiced these, you see it in the exam, it is just giveaway marks. So if we multiply out the brackets here to get 6x squared, we'll call this f of x. 6x squared, and we're going to have 3 by 4 plus 12x minus 10x plus 12x minus 10x, double check, plus 2x minus 20. So 6x squared plus 2x minus 20 is f of x. F of x plus h, you just follow the same procedure, is equal to 6 times x plus h to be squared plus 2 times x plus h minus 20. One thing I always tell my students to do, write down the answer. Well, what if you differentiate 6x squared plus 2x minus 20? You're going to get 12x plus 2. So you should see this appear as you do your answer. So f of x plus h is 6 times x squared plus 2xh plus h squared plus 2x plus 2h minus 20. And getting rid of the bracket, we get 6x squared plus 12xh, 12x, here's the start of it, plus 6h squared plus 2x plus 2h, so my 2 is going to come from the 2h, minus 20. So this is f of x plus h. We have to take away f of x, so minus f of x is equal to minus 6x squared minus 2x, line them up, and plus 20. So if we combine these two lines, we're going to get f of x plus h minus f of x is going to be 12xh plus 6h squared plus 2h. And if we divide this by h, I'll do it in one step here, but I'd recommend just doing it in 2 steps in the exam. But if we divide everything by h here, we're going to get f of x plus h minus f of x divided by h, so the average of these slopes. So we're going to get 12xh divided by h, which is 12x. I'll do the last term second. We're going to get 2h divided by 2, which is 2h divided by h, which is 2, and we're going to get plus on top 6h. So we have our answer at 12x plus 2. So the limit of this function, f of x plus h minus f of x over h, as h tends to 0, is equal to 12x plus 2. Nice easy start. Second part, h of x is equal to half times natural log of 2x plus 3 plus c, where c is a constant, and we're asked to find the derivative of h of x. Well, the natural log of x, if that's f of x, f prime x when we look up the tables is 1 over x. So we have our constant in front, so h prime x is going to be a half times 1 over this guy, 2x plus 3, and then we have to multiply by the differentiated bracket, which is 2. That's the rule for this guy. So the 2's cancel, and we're left with 1 over 2x plus 3. So this is the derivative. And then in the next part, this diagram shows part of the graph of the function h prime x. The shaded region is between the graph and the axis from x equal to 0 to x equal to a, in here all the way along. The shaded region has natural log of 3 square units. Find the value of a. So area under a curve, we're going to get the integral from a back to 0 of its h prime x, which is the 1 over 2x plus 3. Now, if we want to get the integral of something, and we've already differentiated, we just go back to where we started. So the integral of this, we're going to go back to where we started here, which is a half times the natural log of 2x plus 3. Now, because we could put in the c, but they'll cancel when we do the positive and negative parts here. So we're going to be left with half times natural log of 2x plus 3 is equal to the area of this function, which is the natural log of 3. And this is between the bands of a and 0. So I'm going to be left with a half times the natural log. So we're putting a in for x and then 0 in for x, so the natural log of 2a plus 3. And then we're going to have minus a half times the natural log of 2 times 0 plus 3, so just 3. And that's going to be equal to the natural log of 3. Multiply by 2 to get the natural log of 2a plus 3 minus the natural log of 3 is equal to twice the natural log of 3. So we have on the left, well, this is going to give the natural log of 3 squared. On the right, so that's going to give 9. And on the left, we have the difference of two logs, so we're going to get the natural log of 2a plus 3 over 3. Sorry, I left my ln out here. Twice ln 3 is the natural log of 3 squared, the natural log of 9 I suppose to put in. So now I can equate my two parts. So 2a plus 3 over 3 is equal to 9. So 2a plus 3 is equal to 27. 2a is 24. So a is equal to 12.